were provided by the government. Don't forget, 80% jobs were provided by the government and only 20% jobs were provided by the private sector. But after 1991, things changed, and now that's happening nowadays. Now 80% job is providing by private sector and only 20% is providing by the government. So what will happen ultimately? When government is providing job, they are following the reservations and so many other social factors as per the law framed. Whereas in private sector, it's not necessary that they should follow such things. They are totally focusing on skill, the skill of the person, no other factors. You should be employable. You should be fit for their firm. Okay, no other considerations. So, and why that has happened? Because of the liberalization, globalization, and third one, P, privatization. Okay, that's why we found a boom in the what is called educational sector. That's why this many number of educational institutions, health sectors, this many number of medical colleges, tourism sector, a total tourism industry. And again, when I'm saying the tourism industry, remember, before 1991, how many airlines were in India? How many airlines? Only one, owned by the government, Air India. Now you see how many airlines are there because of tourism. So this is the changes happening in the business model. Now once again, you will see the first slide with the century. That is first industrial revolution, that is in the late 18th as well as early 19th. That is mechanization, that's steam and water power. Second one was emergence of new sources of energy source, that is electricity, oil and gas, as well as mass production. Now this time in 2022, see, another energy change is going to happen, that is renewable energy. Okay, solar energy and wind energy, all this going to happen. Another change. At the same time, nanotechnology is playing a great role, miniaturization of all. All this should be considered. And the third one, the third industrial revolution, that is in the second half of the 20th century, that is rise of electronics, telecommunication and computers in the infant stage. Whereas the fourth industrial revolution, fourth one, that is early 21st century, smart, see each and every word, smart system, interconnected system, interconnected means through the internet, then cyber physical systems, cyber connected or net connected real physical systems. That's why IoT, Internet of Things, artificial intelligence, this big data and big data analytics, another area, all those coming into picture. Next slide, same thing, cyber physical systems, fourth one. That is actually happening is digital transformation. That is digitization and networking is the essence of fourth industrial revolution. Total digitalization and a complete network. Okay, even your home totally you can control. You know that. That is mechanization in the 18th, then to 19th, electrification. You see 1984 and 1870. That means 100 years almost. Then again, automation came in 1969. Again, almost 100 years. Whereas Industry 4.0 taking only 41 years. Okay. Now fifth one will take only 10 years and sixth one will take another 5 years. So within next 15 years, we will follow Industry 6.0. Okay. So little bit I will address on Industry 5.0. That is the people working alongside with the robots and smart machines completely. Previously, the manpower, we depend fully on manpower, then a little bit machine power. Later, machine took the full control. Now the peoples are going alongside with robots and smart machines. That is, it's about robots helping human works better and faster by leveraging advanced technologies like IoT and big data. That is, it adds a personal human touch to the industry for pillars of automation and efficiency. Okay, human touch, it should be always there. That's what. Whereas in Industry 4.0, no human touch, fully automation, no human feelings. Okay, fully automation. Whereas in Industry 5, the essence is, we noted that in Industry 4, there is no human touch. So a personal human touch in the final stage, which is the pillar for Industry 5.0. Now, the three essential facts about Industry 5.0. 5 also we want to see. That is, beyond Industry 4.0, Industry 5.0 is aimed at supporting, not superseding humans. Remember, it is to support human beings. Actually, people are afraid one day all this AI supported, artificial intelligence supported computers may supersede a human being. Nothing will happen. It is only supporting, not superseding. Second, Industry 5.0 is about finding the optimal balance of efficiency and productivity for optimum parameters. And the third one is the progress of Industry 5 is unavoidable. We are moving to that area. Actually, even I am an illiterate to live in the Industry 5.0 era. And 6.0 era also I am absolutely illiterate. Okay. The new gen is adjusting with the new era. Now you can see up to Industry 5.0 in a new slide. That is Industry 1, that mechanization, water and steam power 2, that is in 18.800. Then Industry 2, mass production, electric power and assembly line. Mass production and assembly line, which reduced the cost. 100 years later, 1900. Then Industry 3.0, computers, automatic production or automated production and electronics. Another 100 years, 2000. Now Industry 4, 2010 or 11, just 10 years. Cyber physical systems, net connected, real systems, factory, okay, everything fully automated. And in future, pilot don't want to be really in the cockpit. He can sit in home and control the flight. That's the situation. Cyber physical systems, IoT, networking and machine learning. And in Industry 5.0, that is actually now it is 5.0. But we are still thinking about 4.0 only. But in 5.0, that is currently human-robot collaboration. That is robotics, power as well as humans, that emotional aspects. Human-robot collaboration, then cognitive systems. That is with the knowledge, complete knowledge will be transferred to the robot with the support of humans. A cognitive approach and customization of products. That's the beauty of Industry 5.0. You see Industry 2.0, mass production. Mass production, if you are manufacturing 10 lakhs car, it will be unique, 10 lakh, identical, not unique, identical. It's identical. Whereas in Industry 5.0, customization is possible. If one person is demanding an additional feature, the robotic system can automatically do that. Customization is the advantage of Industry 5.0. So the term Industry 5.0 refers to people working alongside robots and smart machines. Cognitive systems are oriented towards human skills and capabilities. That is, robot is blindly a machine. Okay, a smart machine and robot. Whereas cognitive systems where human skills and human capability can be added. So never we can eliminate human being or engineers. That's a message getting from there. Once again, we will see a little bit. That is 1784, that Industry 1.0, 1870, Industry 2.0, 1969, the first time automated production, computers and IT systems, robotics. Then today, that is Industry 4.0, smart factory, autonomous systems, IoT and machine learning. But we want to think what is next, because your job potential is here, not in Industry 4.0, Industry 5.0, where instead of mass production, you can see Industry 1.0 mass production to Industry 5.0 mass customization. It is possible. Mass customization and networked physical systems or cyber physical, not only that, cyber physical, then cognitive systems. Cognitive, that's a new word added. Cyber, if we are simply saying cyber physical, it is Industry 4.0. Cyber physical cognitive system with the human support, human touch. Okay, cognitive systems with from mass production to mass customization. See here 100 years, and here 100 years, and here around 40-41 years, and here only 10 years. Okay, then Industry 6.0 is also there next. Now, for engineers, there is a breakthrough, that is a new era of artificial intelligence, where this communication technology, where we are focused on bandwidth and computational power. bandwidth and computational power. Then second, we are thinking about embedded system, where miniaturization, that is program, is built in on the hardware. Then semantic technologies, that is information integration. All this comes. Okay. Now I think you are familiar with the definition of IT, Internet Information Technology. Okay. Once your companies are coming for campus recruitment, they are preferring circuit branches, CB, that is electrical, EEE, that is EEE, ECE, then computer science, as well as IT. All these are recruited in the information technology companies. IT means, it's again, give a definition like that. Information technology is any technology where data processing, storing, and transformation takes place through a communication media. Information technology is any technology where data processing, storing, and transmission through a communication media takes place. That means electrical branch, electronics branch, as well as computer science plays a great role in IT. That is, information technology is any technology where there is data processing. Data process, very clear, data processing and storing, memory, that is electronics. And transmission takes place, electrical, through a communication media, electronics and communication engineering. Processing means computer science comes into picture. Storing and transmission, okay, electronics comes into picture through a transmission line, maybe wired or wireless, whatever may be. So electrical, all this. Okay. We'll come to the next slide. Now you can think about that information revolution. The change is in the industry 4.0. Everybody and everything is networked. That's a new idea. Everybody. We are also a part of the network. Everybody and everything is networked. Big data and cyber physical systems. That's the essence. Again, you can see the lower part of the slide. Around 1750, that first revolution. And after 100 or more years, 150 years, we are calling it as power revolution. That is, we are capable to develop electric power and centralized electric power system, mass production also. That means here the transformation was from local to global. Okay, a local mechanical production to global level. Again, when you move to 1970, another 100 years, almost not 70 years or more, digital revolution started. Digital computing and communication technology, enhancing systems intelligence. Then from here, you take 40 years, 2010, digital revolution to information revolution, where everybody and everything is networked. Networked information as a human brain. So after 15 to 20 years now onwards, the total world will be a huge brain. All the servers commissioned around the world, all the human being, everything is a huge brain, nothing more than that. That word, human brain, total world is a human brain. You can see, the top you can see, it is not restricted to industry. Even though our title is Industry 4.0, this concept is not restricted to industry. The cyber physical system in all areas. Okay, let's say the Tesla is giving a comment, the earth converted into a human brain. Okay, complete brain. You can see their smart metering. Nowadays, KCB is planning to give that smart metering for electrical power, building automation house, smart grid, a total smart environment, room automation, completely, everything. Now you can see here, Education 4.0. Actually, in today's talk, we want to address little bit. Corresponding to this changes, we want adaptive changes in the education also. Now, the time informatics. For olden days, even 20 years back or 10 years back, we thought mechanical engineering is a different branch. No way related to circuit branch. Okay, NCB. Mechanical was considered as an NCB, non-circuit branch. Now, it is merging. You can see here, that is, all these things becomes a major part of mechanical engineering because manufacturing sector, this IoT and everything is going to play a great role. So, major part of mechanical engineering. Nowadays, we believe that signal processing is role of a job of electronics and communication peoples. Not that. Even mechanical peoples are familiar with that nowadays. Major part of mechanical where virtual production comes into picture, product design, e-engineering, digital machine construction. Okay. And orientation towards digital construction comes. Okay. Completely. And here you can see the employee of Industry 4.0. So the current trend, employee of Industry 4.0, whatever be the specialization, whether it is mechanical or other branch, he should be familiar with this informatics, because clearly they mentioned employee of industry. Another word you can see here, scientific programming, that is coding job. Scientific programming, that means flowchart development as well as algorithm and coding. Formerly we thought algorithm is the job of computer science engineers. Later we realized for machine learning and other things, it's a part of role of electronics engineers. Later when soft computing came into picture, we realized it is applicable to all branches of engineering. And now once we are moving to Industry 4.0, scientific programming and coding should be known to all engineering graduates irrespective of their branch. You can see this. Now it's little bit I am moving to education side. From interdisciplinary science to education. That's why actually in the olden days there was only civil engineering and military engineering. Even nowadays we suspect why this construction engineering we are calling it as civil engineering. Civil and military engineering. Later on mechanization we changed, branches changed as mechanical. Then once electric power came into picture, that electrical. Then that was through a wired transmission line. When there was a wireless transmission, another branch with the invention of transistor and all those, electronics came into picture like that. But nowadays, there is no divergence of branches. Branches are converging back. All branches are converging back to interdisciplinary engineering. Interdisciplinary, and correspondingly we should go for education. Some examples are here. Okay. This is the new field of work where social robotics you can see. Interaction between human being and robot. Social robotics. Here you can see automated driving. You know that automated driving nowadays, autonomous vehicles, robots, everything. Okay, business computing, smart logistics, transportation, human machine interaction, that spelling is wrong, all those. Otherwise, in the next slide we can see that Industry 4.0, that CPS, cyber physical systems and cyber physical production systems. In academics nowadays we are studying embedded system along with VLSI or some subjects, along with microcontroller and all those. We may study embedded system, that is only in the academic level. Beyond that, correspondingly, smart sensor, where there is microcontroller as well as other chips, smart sensors. Beyond that, smart sensor and automatically it can actuate. Actuators are there. Based on the response from the smart sensors, the processor can take the programs, it can run the programs, it can take a decision, and it can go for actuator. Up to here, little bit we know, but from here, actually these two diagrams are same. Only thing is, in the CPS, one antenna is shown. Here, no antenna. Smart systems, smart sensors and actuator, no antenna. Whereas here you can see antenna, that Wi-Fi symbol you can see here. That is cyber physical. This part is cyber, this part is physical system. And then cyber physical production systems, CPPS. You can see a mini assembly line. Everything is happening. And nowadays, even this happening. We are designing chip in Bangalore, VLSI chips for different applications. We are developing, and we are not sending that. On the spot, we can take it, manufacture it at Korea or Japan in the foundry. In the chip foundry, it can be fabricated. It is as good as in a networked printer. You can give a print command from the Department of EC or electrical, it will be printed on the CCF, like that. A complete network. Oops. Next slide you can see. This mass customization is the essence of Industry 4.0 and 5. That is a marketing and manufacturing technique that combines the flexibility and the personalization of custom-made products. That's a beauty. Custom-made products with a low unit cost associated with the mass production. olden days cost was too much. Once mass production came into picture, the cost reduced. We are not ready for custom products because cost will be more. Okay. Whereas with the Industry 4.0 concepts, the custom made products is possible with the low cost. Okay. Our other names of mass customization include made to order or built to order. Okay. When we are buying ready-made shirt, cost is less because of mass production. So in future, even for our own design, our own customized shirt, they will charge the same. Okay, that's the beauty. Now we'll see some other aspects. The 6 technological waves that will shape the customer relationship in the future. Industry 4.0 and beyond. That mobile evolution, already we know that. We are moving to 5G, 6G and all those. Cloud computing, somewhat knowing. Now, instead of Internet of Things or IIoT, Industrial Internet of Things, we are moving to IoE, Internet of Everything. Then robotics and CNC machines, robots and CNC, computer numerical control machines, 3D printers, you heard somewhat, and AI, artificial intelligence. Now, we are moving to the corresponding education part. If there is Industry 4.0, there must be engineering education 4.0. It should be in phase. Okay. That means, I told, up to 1950, we focused on design-oriented engineering education. Unfortunately, still nowadays also, we are following almost that, without giving importance to skill. Skill is no way accounted. Only the rank syndrome or grade syndrome. Okay, grade syndrome. Nothing beyond that. Around 5 to 6 years, I was training and placement officer at CET. Most of the time, I found the way companies are approaching and what they need from the student. They are not at all focusing on the grade and all those. Of course, they are putting no arrear conditions. Still, they won't focus about the grades. They will test the honesty. They will test the assessment skill, the logical thinking skill. As I told earlier, the skill, the employability of the student, all those factors. How sincere and how honest he is, all those. They have so many techniques to test that. That's a huge topic. Here we can't address. So in the engineering education, the fourth industrial revolution, the modernization, sustainability. You know that sustainability, the concept. For engineering students, you have a paper, sustainable engineering. For diploma holders, they may not have. Still, you can refer the sustainability. Okay. Then research and innovations. So when I am saying the word innovation, I want to distinguish between this engineering and the technology. Okay. Actually, engineering is actually innovation. Engineering is innovation, and technology is actually implementation. Okay. Most of you doubt our degree is BTech, and we are saying we are studying for engineering. Okay. MBA student, if you are asking, he will say, I am studying business administration. MSc student or BSc, he will say, I am studying science. BCom student, he will say, I am studying commerce. But you people, even us, we will say, we are studying engineering, but our degree is in Kerala, it is BTech or MTech. But in most of the other states, it's B or ME. That means there is a difference actually in engineering and technology. Engineering itself is one of the technology, like textile technology or food technology, wood technology, anything, information technology. Engineering is also one of the technology where in engineering the focus is on innovation, innovative idea, whereas in technology how we can implement that without failure. Now comes to higher education, and here you can see the research and innovations are primary interventions in all segments of commercial and social activities. Okay. Commercial and social activities. Social activity you can see here. Now, if you know, you just go through the outcome-based education program objectives. You can see in that you see beyond 5. You can see it is related to social activities. And the new syllabus of KTU and other universities, they are adding law syllabus, some little bit of biology, some little bit Indian history, so many things. We may think whether these people are making us foolish, why we want to know this law and all those. The reason is very clear, it is based on engineering 4.0, the social, because a social, modern days, nowadays, or engineering design should be eco-friendly, it should be sustainable with a human touch. Sustainable with a human touch. Sustainable means three things should satisfy. Our design, our product, it should not be harmful to the society. First of all, it should not be harmful to the society. Second one, it should not be harmful to the environment. That is sustainable. That is, at the time of design itself, you should ensure that it should not be harmful to the society. It should not be harmful to the environment. Third, it should not be harmful to the nation. It should not affect the nation. Okay. All these three should come into picture. Then only that system is sustainable. Okay. Mercury. Have you heard about mercury? Nowadays, no mercury supported products because it's not eco-friendly. It's not sustainable. During our times, our educational period, there's so many products with the mercury, even mercury thermometer. That itself nowadays vanished. And because of COVID, is it? They have new thermal scanners. Okay. That is another example for humans or engineers, basic principle. That is man doing things from needs. Man doing things from needs. This thermometer was 100 years, more than 100 years old. So many engineers was here. Nobody thought about a thermal scanner. Once we realized that it is not feasible in the pandemic situation, we moved to thermal scanners. Amazing. Now, once you are coming to higher education, is being globalized. I told in the earlier classes, 1991, India entered into LPG era, liberalization, privatization, globalization era. Okay. Then the role of information and communication technologies, especially in engineering education, is prominent. Okay. That's why, irrespective of branches, we should follow this information and communication technology in the syllabus. That's why KTU and other technological universities saying that credits can be acquired from online courses also, MOOC courses. You know that, MOOC courses or other courses. Even now itself, KTU is saying, not only KTU, other technology universities like Vishishree, VTU, Bangalore, VTU, Belgaum, and other universities, and a university saying only 80% you need to acquire from campus, 20% you can go for online courses. Okay. Now we'll see. Engineering education 4.0 is a pedagogical approach, teaching approach, inspired by the fourth industrial revolution. That means corresponding to industry 4.0, there must be correspondingly engineering education 4.0 by the fourth industrial revolution for satisfaction, time saving, skill development. Don't forget the skill development, efficiency enhancement in engineering education. So many things going to change. In the further slides, you can see that. That is, efficiency enhancement is one of the things. Okay. Even resource utilization is another idea. It's not mentioned in the syllabus here, not included in the resource information. For example, nowadays, CET is going to buy a special grade computer with 2 crore. At the same time, it is available in the RIT quota. That is no resource sharing. Okay, that is device utilization factor or equipment utilization factor or system utilization factor is less. We have the net technology, so why can't we exchange it, that supercomputer from the other institute? That utility is very less. Once in a month, 2 research students may prefer that or utilize that. That means not only efficiency enhancement, but utility factor of the systems also will be accounted. Utility factor. That means even for faculty won't stick in one institute. Physically, he will be in one institute. Virtually, he will be available anywhere in India. That's a scheme AICT is going to provide. Already, circulars issued in that way. Okay. This is what is happening. I'm physically sitting in CET, but for getting my service, you don't want me physically there. Okay. So many changes. Now, from curriculum development to assessment, generation of results, and student feedback, all important tasks and activities are accomplished by the assistance of information and communication technologies. Okay. Even KTU, almost it's a paperless things. Everything is paperless. You can see next slide. But what are the challenges here? Challenges we are facing. The current challenges towards technology-enabled teaching, learning, and engineering education can be as follows. Here you can see the word teaching, learning. Students, please see teaching, learning. Up to +2, you can expect teaching. Then +2 onwards, that is in engineering college, you should focus on learning, not teaching. Basically, the faculty's duty is not to teach, but to mentor in higher education. Whereas in school education, we are calling them as teacher because they are supposed to teach. That's why government is saying they should have a B.Ed, Bachelor of Education degree, along with their specialization, say MSc or MA, whatever may be, because they are teaching. But once you are coming to higher education, even public nowadays also calling us as teacher. Basically, we are not teacher, but faculty, that is group of professors. That is faculty. Our job is mentoring. Mentoring is our task. If we are trying to teach, you won't get better quality in education. We should actually mentor you, train you for learning. All the resources you can take. Okay. But still, it is unfortunate that students are demanding notes. Okay. If you are collecting notes, temporary it is okay. For a short span of time, it will be okay. But for a long time, it won't sustain. And these are the things. Once we are addressing Industry 4.0, corresponding engineering education 0. One is, it needs initial expensive involvement in exploring. Initial investment, initial extensive involvement. First, it needs, rather than investment, of course, investment is another criteria. It needs initial extensive involvement. Second, training all faculty for that and understanding the aspects of technology in order to prepare for its implementation. The main failure of even OBE, outcome-based education for NBA accreditation, National Board of Accreditation, the main problem is the concept is not clear to the education arena. That's why. Now, demotivation of the students and stakeholders is another problem here. Demotivation of the students and stakeholders means the students, parents, faculty, all are stakeholders because their interest and comfort zone both lie around the traditional methods. That's the problem. That's why even after changing from rank to grade, the 10th class, that is still that from rank syndrome, it is changed to grade syndrome, nothing more than that. Full A+ banners. Actually, the government's intention was to stop that rank syndrome. Because of that, the reason is our comfort zone, which lies around the traditional methods. So it is very difficult to change. Now, cost is also a big factor. Previously, I told cost more expensive for the successful functioning of engineering education 4.0. Now, implementation is very difficult as it needs continuous motivation, transfer of skills and funding. Okay, that continuous motivation is required. One class or not, it's insufficient. Transfer of skills also. Now, I told about digitalization. So digitalization is one of the innovative results of the recent Industry 4.0 developments, improving the quality of life, now correspondingly increasing the productivity of labor. That's why the manufacturing sector, Industry 4.0 concept plays great role, productivity. Although it requires much needed investments and economic prosperity, companies are eager to adapt digitalization and make associated changes in their working environment. Please remember, those who are awaiting campus recruitment, companies are waiting for even changing to digitalization and make associated changes in their working environment to increase their competitiveness. Digitalization results with the change of workforce. See, digitalization results with the change of workforce. That means many will lose job. It never means that effectively they are losing job, provided they are trained to the new system. A simple example, some 30 years back, you can see in our town cities, a typist typing in an ordinary mechanical machine. Around 30 years back, or even before that. But later, when electronic typewriter came into picture, we can see the same lady is sitting there with electronic typewriter. Same lady. Usually ladies are sitting in type institute to type or paperworks, affidavits and all those, so many. Same person. Later changed it to DTP. Then also the same lady is sitting. She is comfortable with providing DTP. Most of such shops have this passport service. Olden days they will type in the mechanical typewriter. Then they used electronic typewriter. Then they took DTP. Then online passport application. The same lady, they will collect our Aadhaar and other things. She will do online and advise us, go to this passport office or passport service center, Seva Kendra, on this day. Everything, same thing. And once WhatsApp came into picture, the same lady will tell us, just provide the data, you go to your home, you will get all the details in WhatsApp. The receipt for uploading, generated application form, everything. And even the status, your passport is under process, your passport dispatched, everything is available. That means the lady was accept to the changes. Otherwise, she will lose job. Okay. That's the thing. That means a change of workforce structure and their qualified requirements. If she is saying that I know only typing with the mechanical and stenography only I know. If she is saying only I know stenography, she will lose job. The qualified requirement will change. That date was changing with the 10 to 15 years. Now it is changing with every 2 to 3 years. And in the IT arena, it is 1 year or even less. Okay, that's a pathetic thing actually, because I observed that in IT companies in Bangalore and Hyderabad when I am visiting, some ladies when they are taking maternity leave for 1 year, naturally it's their right. Once they are coming back, it is very difficult to them to adjust that firm, because within 1 year everything will change. Okay, but in our educational institution, if you are taking even 25 years leave and going abroad, nothing will happen. On the 26th year, we can work. The same syllabus, the same thing is happening. Almost the same syllabus. Only syllabus revision means a little bit changes, but fundamental things same. That's the beauty of this academic institutions. Even after a gap, we can work. Whereas in industry, it is very difficult nowadays. Okay. Namely, new jobs are to appear. See this sentence? New jobs are to appear while some others are to disappear. Okay, disappear. Even faculty, teaching community, faculty is also actually losing job, because this 20% online gradually will make it as 60-40, 40%, then 50-50, then foreign universities are into picture, complete online education. It's changing like that. Okay, situations. So we should be adaptable to what is the changes. Now, employees will therefore have to adapt their skills to keep pace as well as to develop new skills and meet new challenges. That's why in the program outcome, in the 12th one, lifelong learning, outcome-based education. I think in your institute, this poster may be there. Or you can search in Google. Those who are not familiar with outcome-based education, search in Google, outcome-based education, 12 program objectives, or National Board of Accreditation, something like that you can type, you can see. Out of the 12, up to 5 it is related to academics, 6 to 12 it is related to general skills and other aspects. So then 12th one is lifelong learning. Lifelong learning is the new concept. Now with recent Industry 4.0, the technological developments, employees are to be replaced by automation. See, very dangerous. Employees are to be replaced by automation, robots, artificial intelligence implementations. That means resulting with a decreased number of employees in the working environment. Decreasing number of employees. This is the danger going to happen. But at the same time, in the automation environment, very highly specialized engineers will play a role. Okay. Now, this development will not only lead to a reduction in the number of employees, not only that, reducing the number of employees, but also it is expected that there will be a shift towards higher quality. The requirement, the quality requirement of the employee also changes, and more intellectuality in employee structure is coming. Now, the future of engineering education. The higher education tends to gain more prominence given how profoundly the world of workforce structure is changing. It's happening all over the world. The workforce is changing. We may surprise the new gen students once getting their graduation, that is B.Tech. They are getting huge pay in some companies because their target is like that. They know they need a workforce with all these skills. The main questions arises are how higher education should prepare students to succeed in an evolving global information economy. How the higher education should prepare students. That's why our government is planning the new projects under the Higher Education Council. There is changes are going to happen. And I think the K2 syllabus next academic year, I think, along with the regular subjects in the timetable itself, 1 hour for 1 or 2 hours, I think, for skill development is there. Probably in the next syllabus revision, along with the regular technical or technological subjects, 1 or 2 hours per week comes under skill development. The reason is very clear. This idea. Now, what skills should be earned by the students by the time they graduate? Unfortunately, till graduation, we are focusing only on grade. And how can they best be equipped with those skills? This is the idea. Now, the new engineering education says skill-based. Previously, I told SETA, skill, employability, trainability, and adaptability. The first one is skill-based training education. That is the National Research Council, 10 years back in USA, released a report saying that broad skills required for the future graduates, broad skills. But whether we are ready for that, still we are in the rank syndrome or grade syndrome, full A+ syndrome, assignment syndrome, so many. It is described as 21st century skills. You can even refer in the net with the 21st century engineers skills, something like that. You will get plenty of materials. It is a mix of cognitive based on their intellectual level, cognitive, intrapersonal and interpersonal attributes such as collaboration and teamwork. Teamwork is very essential nowadays in engineering. Okay. Globally, when we are working, teamwork means both, not only both, male, female, transgender, all the three may work together. Engineers from different countries may work together. Rather than different countries, countries with disputes may work together. Say in Dubai, engineers from Pakistan, engineers from India, China, USA, Russia will work together. Only at government level there is a dispute. As an individual, there is no dispute. So their teamwork is expected. Similarly, their food may differ. Somebody may be non-veg, somebody may be veg. Even Koreans' food culture is different. Our food culture is different. Middle East food culture is different. But as a team, they are working together, irrespective of all these. So that's why teamwork is a major thing nowadays. Then creativity or creative thinking. Creativity and imagination. That's the purpose of your first year drawing. Unfortunately, now it is reduced as drafting or sketching, something like that. And no draft writing nowadays, mini drafter. Your imagination skills also should be developed. Your creativity as well as your critical thinking, not even thinking. IT companies are nowadays testing your critical thinking capability and your problem solving skills most of the time. You should be fit for campus recruitments or even outside, off campus or on campus, both off campus also. You should be ready with your critical thinking skills, your problem solving skills, your creativity, your idea on coding, very essential. Whatever be the work, even hardware companies also prefers your skill for coding, data structure idea, everything. Even little bit algorithms, soft computing algorithms. Now, second is technology-based and student-oriented education. Second change is completely ICT, technology-based as well as student-oriented. Okay, student-centered actually. Now, competency-based. Actually, unfortunately, in higher education, still we are following school-type teaching. Faculty with a blackboard or with a slide on the platform, students are seeing and copying. No interaction, and it is not student-centered. Okay. Now, this is also going to change. Competency-based education, another concept, is an approach suggesting learning based on development and demonstrating competence. That's why it is called In engineering colleges, it is called PBL, project-based learning, PBL, problem-based learning, something like that, project-based learning. Okay. Rather than assignments, importance for project-based learning. As a part of that, now KT implemented mini project. Okay. That is developing and demonstrating competence. Now, instead of simply sitting in classroom, your interesting area, instead of simply sitting in classroom for a specific time period, 9 to 10 this, 10 to 11 this hour, something like that, instead of sitting, students are allowed to show what they know by moving at their own pace. Very beautiful concept. Students are allowed to show what they know by moving at their own pace. The new educational policy, in the 10th class, students not necessary to study maths if he don't like. He can take some other subjects. The policy says if a person don't wants to come to engineering field or some science graduation, BSc, why in the 10th class he needed to know geometric progression? Of course, arithmetic he needed to know, arithmetic. Why he needed to know geographic progression or some what is called critical mathematics? He don't want statistics and all those. No, basic arithmetic is sufficient. Like that, it is changing. Then, although the competency-based education differ by institution, another thing is it will be differ by institution. But generally, it will be same. The demonstration of mastery of subject through a series of assessment tests, assignments, instead of following a prescribed set of courses. So in future, I think there won't be prescribed courses. The faculty will give some assignments, okay, and some tests. Like we are going for faculty development program. In 5 days, 10 faculty every day, morning and afternoon. Faculty will come. Lot of topics will be addressed on the last day. A test for awarding the certificate. Like that. No specific prescribed set of course. That may be the concept. So in that, if you are acquiring online, it is acceptable. Okay. Next, the digital transformation, as I told earlier, the digital transformation. By these resources, the new demands on higher education and institutions is coming, including developing innovative curricula, study programs, and alternative learning pathways. So our traditional classes won't be there after 10 to 15 years. Totally it is changing. Even if there is traditional classes are there, it will be a flipped classroom. Flipped one. I think you know that. What is a flipped classroom? Now, these are the routes to higher learning facilitated by online programs, distance learning, and open education. Now, blended teaching learning, blended. Even after the first lockdown, we have seen a blended, almost blended teaching. Some classes online, then offline, something like that. And blend delivery models and short skill-based courses. Short skill-based courses such as massive online open courses, MOOCs, and open education resources. Even short skill-based programs. That's why KT is going to implement 1 or 2 hours per week along with the subjects. Now, we heard about the big data analytics, how we are incorporating that in the education. That data analytics, the beauty, see that slide. By integrating in the digital teaching resources, it has become possible to measure and trace the student learning levels, not the class. Usually, formerly we think that division A is good, division B not good. Who told? Division A is good means not all. Division B is not good means no, again not all. That means with the data analytics, the teacher or the faculty in school, the teacher in the college, the mentor, the professor, the faculty can. It is possible to measure and trace the student learning levels individual levels in real time, on the spot, real time, and allow students and professors to adapt their behavior based on the outcomes. This method is usually referred to as data analytics or predictive analytics powered by information bytes created in classrooms every minute of the day, every minute. Okay. That's the beauty of data analytics in engineering education. Definitely in engineering 4.0, this will be adopted. But it will take some delay always. Okay. Now, You can see the speed and complexity of this idea, revolutionary innovations. That is, earlier slide I showed, everybody and everything is networked. Everybody and everything is networked. From first to second, there was local to global. Similarly, from third to fourth, again, local to global. The digital computing was local. Communication technology was local. Automation was local. Industrial robot was local. Now, it became global with the cyber physical systems. Now, we will see the requirements for Industry 4.0 again, which is equally applicable for Engineering 4.0. The IoT, Internet of Things, but now it is changed as one change is IIoT, Industrial Internet of Things. Second is IoE, Internet of Everything, where you can see IoT. Second one is IOS, Internet of Services, and third is Internet of Data, IoD. So IoT, iOS, and IoD. Again, come back to that education, the future engineering education. What are the implications of Industry 4.0 correspondingly Engineering 4.0 education as well as beyond 5.0. Excellence through interdisciplinary. That's why previously I told we are going to change to interdisciplinary, even transdisciplinary. Interdisciplinary itself is old now. Transdisciplinary. Interdisciplinary means between different branches or specializations in engineering. Transdisciplinary means with other arena, other domains, say medical, nowadays biomedical. Okay, many electronics engineers are familiar with the pace, the heart and all signals and all those, that PQRS waveform of the what's called human being generated, everything. They know some biomedical aspects. Similarly, biomedical, some doctors are familiar with these equipments and its functioning. Interdisciplinary. That is excellence through interdisciplinary. Without interdisciplinary, there is no innovation. That's a new concept. Innovation means engineering. Okay, not implementation. Implementation is technology. Development of highly complex socio-technical systems. Socio-technical. Previously I told you, sustainable. Okay, when we are going for technology development, it should be socially viable. It should not be harmful to the society or environment. It requires the collaboration of various academic disciplines. Various. In future, when an engineer is designing a product, he should be familiar with somewhat law enforced in the country. What's the law? He can't add what's called cadmium or say mercury in that device. There is restrictions. That means various disciplines he should be familiar. That's why he should be ready to learn little bit law also. That's why in the new syllabus, I think law also comes into picture. Second one, I told in the earlier time, SETA, S-C-T-S, skill, employability, trainability, adaptability. That adaptability to rapid innovation cycles. Nowadays, the 17th, 18th century man don't want to be adaptive so much because it takes 100 years for a change. Training office with this much changes. Now, students need less, remember this, students need less detailed specialized content than the ability of lifelong learning. Okay. Less content, you should focus on lifelong. The future engineers need the skills to adapt to the changes quickly. Remember this sentence, future engineers need the skills to adapt the changes quickly. That's what I told last one, SETA, adaptability. Because every 1 year or 1 year, 6 months, it is changing. Next is survival in Industry 4.0 requires IT skills. Actually, it is another paradigm shift, a complete change to 4.0. For survival, for an engineer or for an employee, even in that Industry 4.0, he needs IT skills. That's why our generations are actually illiterate, I can say in that sense. IT is the main driver of innovation in future industrial contexts, independent of the specialization. Remember this, independent of the specialization, engineers must have basic knowledge and understanding of others, even signal processing, other things, IT concepts. Future engineers need to be able to speak code. Very important sentence. Future engineers need to be able to speak code. That means actually write code. In campus interview, one student can't say, I am from mechanical background, I don't know about coding. He will be out. Because in a machine, based on the functioning of the machine, he should be able to write code. Because so many mechanical terms will come into picture. Electronics engineer may not be familiar with that terms. Computer science engineers may not be familiar. Only mechanical engineer is familiar with that technical terms. Based on that, he should be able to write a code. So survival, what are the things? Your IT skills, then must have basic knowledge and understanding of other branches irrespective. That's why KTU implemented minor. You are thinking you are studying in mechanical branch, you are taking minor in electronics, or electronics you are taking minor in computer science, something like. The purpose of minor is very clear now. Now, future engineers needed to be able to speak code irrespective of their branches. Next, you can see what are the implications for future education. Fourth one, the new business thinking. Above the classical basic thinking, so far we called it as classical basic thinking. We need to manage development projects, future entrepreneurs, actually now techno entrepreneurs, technology entrepreneurs. Future entrepreneurs need additional skills, in particular leadership, decision making, and all those. They needed to know to communicate business idea to stakeholders, and the concept is future engineers needed to know how to collaborate in the global village. After 1991 LPG era, we are using the word global village. Okay. Now the fifth one, taking risk and dealing with uncertainty. That's another issue. Uncertainty cannot be managed. Even the best prediction will, technologically or technically with the prediction, even the best prediction will end up as only partially correct. Prediction. See this word prediction. When we are seeing the word prediction, I want to remind you two things. Our branch, electronics and communication, is a what is called a predictive branch. Actually, our studies are based on predictive models. That's why we are studying probability most of the time. We are saying probability that electron lie in the K shell or somewhere. A probability density function. Predictive models. No physical experiments. Whereas mechanical is a deterministic branch. Deterministic models are possible for them based on the experimental results. Deterministic. Whereas the circuit branches, CB, it is predictive models. So probability is essential. And even with a good prediction, best prediction with the best model, it may be only partially correct. Okay. That's why the scientist is saying all models are wrong, but some are useful. All models are wrong, some are useful. And another thing I want to remind here, model. When I'm using the word model, what is the difference between the job of a scientist as well as engineer? Most of the time, the IT people are asking that. Because whether you are familiar with your job, okay, they are in MSc also, they are studying this subject, same thing what we are studying in BTech. But what's the difference? Okay, that is actually with respect to models. Scientists are actually observing the nature and making a mathematical model. That's the job of the scientist. Observe the nature, whatever the things you are seeing in the nature, that behavior, make a mathematical model. Whereas engineers will see the model and he will try to make an approximate reality. That is, scientist makes model from reality. Engineers makes approximate reality from model. Why approximate reality? The model will be approximate. Even if the scientist is giving the real model for construction purpose or manufacturing or design purpose, engineers will go for so many what is called reductions in that model. So many times he will assume it is constant, something like that. Finally, he will take an optimum model, which is not exactly the original behavior. So naturally, once we are converting back to a model to a reality, it will be approximate. So scientists observe the nature and makes an approximate model or a model, whereas engineers will observe the model and make an approximate reality. This is happening. So the model is the common area where mathematicians plays the role. Mathematician will reduce the model complexity. Okay. So actually from left to center point model, task of scientist. From center point model to right side. Innovation, from that model, you want to go for innovation. That is engineering job. Then once innovation is there, we want to implement it practically how it is possible. That is technology level. Okay. So left side, scientist job. Then middle you can see mathematician's role, that is optimizing the models. Then engineering, that is innovation from the model. And finally implementation. Even if the innovation is there, practically so many difficulties are there. You want to overcome. That's the technology. Now future engineers need to be unterrified and capable to adapt to the changes quickly and broad competencies. And sixth one, bursting with creativity. When speed of innovation cycle increases, now the changes are very fast. Creativity becomes the new gold. Students need the ability to critically assess the issues and develop sound or responsible creative solutions. Okay, this is very important. That's why IT company is always giving a problem and will give you 30 minutes time to demand you to find a solution. Most of the students will give a solution, but they will see the optimum solution. Say out of 100 candidates written test, they may opt 20 only for final interview. From that, they may opt only 4 or 5. This is the way. Next one you can see. Seventh one, individualization. That is, institutions and teachers must be open-minded for such new concepts and also gain the necessary competencies. This is going to change. And the digital natives, the future students want these concepts. They are used to fits me content. That is, if it is not offered, they are likely to lose the interest. That fit me concept. You should be ready for all the adaptive changes. Now the eighth one is curriculum and certificates. Very interesting thing you can see. The traditional business model of universities becomes disrupted. The current KTU or other universities all over the world. The traditional nowadays, the traditional business model is there for education. The universities and that model, traditional business becomes disrupted. The curriculum must be flexible in order to allow, example, their shortening or extension according to the individual student needs. Nowadays, we cannot change the syllabus at all. Okay, whereas in future, in the engineering 4.0 education, if the student is saying that chapter is not so, we need this chapter along with that. You know, not only transistor is mentioned in the syllabus, we need a MOSFET also. Mechanical students saying only 2-stroke engines are there in the syllabus, but 2-stroke engine 4 modules are there. The fourth one skip and add 4-stroke engine also. Something like that. Okay. That means students are empowered to change the syllabus. Unbelievable. The curriculum must be flexible to allow even shortening or extension according to the individual student needs. Individual, that word is very important. Individual. If majority, like your elective subject, if 10 students are saying this elective we need, they will get. If it depends on not the classroom, individual student needs. Okay. For one student alone, we can change. But we don't want to teach. We want to only mentor. He will collect the materials. Okay. The recognition of this MOOC credits. You can get you also allowing this. The recognition of MOOC credits from various education providers all over the world, from any university, you can collect. The new quality measurements are needed to support the process of certificates. So you can claim from anywhere, from any university, you can go for an online course and you can, but KTU currently permits up to 20% only maximum. Now, access, privacy and transparent. That are the new rules. Who can access? When can access? Where can access? This access the students' data. All this in the cloud. Okay. Even nowadays, little bit it is there in the KTU. I am loading the mark. Only the staff advisor can see that. We are loading the marks, but only one student can see only his mark. Okay. Like that. That means in order to execute the necessary analytics and privacy issues occur, and how are we going to deal that? That are the issues coming in 4.0 engineering education, legal problems. Okay. Now, I am concluding in the 3 steps, almost the final stage, 3 steps. The 4th industrial revolution, where we are in the middle of 4th industrial revolution, where IT and artificial intelligence plays a role. Big data and learning analytics, like big data analytics, learning analytics, so that we can measure the performance of individual, not the classroom or college. Nowadays, we are saying that college is good. Sometimes inside the college, we will say this department is good. Sometimes we say S6 is good, S4 is weak, something like that, generalized. No, in future, we can individually say in that classroom, 6 in this way good, other 6 are say in this way. We can measure. We can't use the word bad. Nobody is bad according to the new concept. Nobody is bad. 6 are good in coding, okay. Another 10 are good in design, something like that. Another 10 are good in creative work. Another say 5 are good in reasoning and ability, test of aptitude test, arithmetical skills and all those. That means their job nature will be changing. Okay. And I think KTU is also planning to implement that diploma, BVOC and BTech. I think you know that. Most of the Indian universities is going to implement that so that everybody will get a degree. In the 4 years BTech, if you are able to complete only first 2 years, you will get a diploma. Once you are able to complete the 3rd year, you will get BVOC, Bachelor of Vocation. And once you are completing 4th year, you will get BTech. So everybody is getting a degree or some certificate. Okay. Now, innovation and entrepreneurship is another platform. Okay. With this, I am winding. It took 1 hour, 20 minutes. Okay. So thank you all for your patience. If you have any queries, you can please. Anybody, please? Admin? Google admin, please.
If anyone has
audience,
questions, please ask.
Somebody from the student side only, please respond whether it was useful. This 1 hour, 20 minutes talk to some way. Somebody, please unmute the mic and reply. Partially okay or good or somewhat, some knowledge. Not a comparison of my classes, whether the information was useful, that's all. Anybody, please? Panchumol KN? Anybody? Yeah, good. Yeah. Yes, sir. Class was useful by Kevin K. Gladin. Okay. Others? So you can refer all these concepts in network. My request to students is not only focus on the syllabus. Of course, syllabus is required for you getting good grade and all those. Addition to that, instead of wasting time in the campus as well as holidays, please focus on latest things. You don't want to study and to be a master of coding. I won't say that. You don't want to be a master of machine learning. You don't want to be a master of artificial intelligence. You don't want to be a master of IoT, but some basic. Because the interview panel may ask you one question, then you can say 1 or 2 points. That is enough. So they believe that you have the taste, they can train you. You are fit for their firm. That's only concept. Okay, Sandeep Santosh saying it is very useful class. Okay, thank you. Anybody, please? Otherwise, the admin can wind up, please. Yeah, Sandeep Santosh is saying informative. This is the end of the session. The group admin can address and can wind up.
Thank you, sir. Next, I would like to invite in Siddharth to do the vote of thanks.
I would like to thank Dr. Suresh Kumar sir for giving this wonderful session in the limited time. Next, I would like to thank our principal Dr. Sanjana ma'am and principal in charge of Snmimt Polytechnic, Pradeep sir, for their precious presence and time. I also thank our staff coordinators, Babi Miss and Shafna Miss, and other teaching and non-teaching staffs. Last but not the least, I would like to thank every students. Thank you all.
Thank you, Siddharth. E-certificates are available for all the participants. Links are shared below. Thank you all.
Thank you all. Thank you for the patience. Thank you. And thank you for the institution also for giving me this opportunity. Thank you.